Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science Physics Paper 2 High Tier from 2018. Question number 2 is on the topic of magnetism. A magnet produces a magnetic field. Which diagram shows the magnetic field pattern around a bar magnet? So you have North Pole and South Pole. The key thing to remember is that the magnetic fields have a direction which is from north to south. So it should go from north to south. So here it's actually going from the south to the north. First one is correct, north, going away from the north towards the south, and on both sides it's going from the north to the south. This one is incorrect. It's definitely not going around in a circle like this, like a track. So it is number 1. Figure 3 shows 3 metal blocks. The blocks are not labeled. The blocks are not labeled. One block is a permanent magnet, one is iron, and one is aluminium. Describe how another permanent magnet can be used to identify the 3 blocks. So, how do you use another permanent magnet? Well, if you had another permanent magnet, north and south, what would happen to these 3 blocks? Let's say this is the permanent magnet, and this one is iron, and this is aluminium. In the color aluminium. So what would happen when I bring this permanent magnet closer to the permanent magnet? If it was a permanent magnet, it would attract or repel. So attract or, depending on the polarity. So if it was a north pole here and the south pole is there, it's going to repel, and if the poles were reversed, it would attract. Iron, it would simply attract only. It's not going to repel. Aluminium, well, it's not, aluminium is not magnetic, so no attraction or repulsion. There's no reaction, you could say. So here's the answer. Permanent magnet has no effect on the aluminium. Iron is attracted to the permanent magnet. Only the permanent magnet can be repelled by the permanent magnet. 2.3, figure 4 shows a toy crane. You got an electromagnet at the end, which is hanging by a thread, blocks made from magnetic materials, and a switch. The toy crane uses a electromagnet to pick up and move the blocks. Explain how this electromagnet is able to pick up and move the blocks. Okay, so when the switch is pressed, a current goes through the wire, and the current goes through along to the wire, and what you have is this U-shaped or horseshoe iron core, right? And these are the coils of wire. So when a current passes through the coil of wire, it produces a magnetic field, and the iron core actually makes that magnetic field stronger, and the iron core becomes a magnet. And when you lower the electromagnet, it's going to attract the blocks because it's made out of magnetic materials, and it will stick into the electromagnet, and then you can move it, and then you press this switch again to once you move it to a new spot, it would cut off the current, disabling the current. The iron core stops being a magnet and lets go of the magnetic block. That's how basically it works. So here's a model answer. Completing the circuit turns the electromagnet on. There is a current in the coil. A magnetic field is produced around the coil. So the iron core becomes magnetized. Moving the electromagnet. Let's say moving the electromagnet towards the blocks. The block is attracted to the electromagnet. Moving the crane moves the block. Switching off the current switches off the electromagnet, releasing the block. And that is the end of this question. Thanks for watching, and I will see you in question number